All right, so welcome back to another JNCIE-SP video. This is the weekend video. So I didn't start strictly right at noon as I would during a workday video. I wanted to do one in the morning, but I think this is a decent time because I still have that cron job set up. It'll work during the weekend as well, so definitely don't want to get just interrupted for randomly in the middle of a video. So now is, I think, a better time. All right, so I will share my screen and we'll continue where we left off last time. All right, and let's see here. All right, and I made these delicious peppers, so I will be eating them. Okay, so where we left off last time, we made some goals for the routing loop topic. So hopefully we'll be able to complete those, and this will just be a 2-video topic. I really don't want to give too much time on it. Last video we spent a lot of time reading, so this video we'll just do some practical stuff and give it about an hour max, and no matter where I get, I think I will mark this complete at the end of this video. But let's try something interesting. Let's try setting up OSPF on routers 1 and 3 and ISIS on routers 2 and 4, and then we'll try redistributing routes between the two protocols and see if we can create a loop. So yeah, let's try that. It's a bit dangerous because it might just spike everything up to So here's the magic of junipers. What we can do when we create that loop is do a commit confirmed and then just have it roll back in 3 minutes, and we can look at our traffic statistics and see how everything changes from when there was a loop to when there was not. And just having 3 minutes of a routing loop in a 4-router topology, I don't think will be that big of an issue. So yeah, I think that's the best way to proceed. So router 1, and we can see we're at the login prompt, so the cron job worked. Router 1, I think all of the routers now are configured with ISIS. Yep. Okay, so we won't need anything extra to set up routers 2 and 4, but routers 1 and 3 will need to be converted to OSPF. For anyone wondering, no, these are not jalapenos or serranos. They're generally very mild, but there is 1 or 2 in the batch that can be a bit spicy. All right, so let's see here. Edit. So let's do this just because I want to get used to doing this, and I think it will save a little bit of time. Let's do deactivate. So instead of actually removing the configuration, we're just going to make it so that it doesn't do anything. Okay, so we could either do a delete, we could do a deactivate. It would have the same final effects, but the difference being if we did a deactivate, it would still show up in the configuration, it just wouldn't do anything. So if we wanted to activate it again, we've got a much easier job if we used deactivate than if we used delete. Okay, and let's use OSPF version 3 just because it's going to be the more important one to learn. Version 2 has a pretty big limitation where it can't support IPv6. Okay, so everything should be good to go now. Let's verify that there are OSPF version 3 neighbors. Okay, so we've got a neighbor across the link local address, which I'm kind of surprised because I thought I had IPv4 addresses set up on here. And I do. Looks like I've still got issues where there's duplicates on there, though. It's kind of frustrating because I thought I had that all worked out. Looks like it's worked out on here. Let's see which one pings and which one does not. Okay, so it looks like that 5.2 isn't accurate. Let's just double check and make sure this works. Okay, so we'll get rid of that statement. We will do a delete this time instead of a deactivate because it's just erroneous config. All right, so now we should be learning one route through OSPF now, and it's the route on this link here. We won't be learning this route though because it's just in this ISIS, so we won't learn it until we redistribute that route. So it looks like we got two routes, which is not what I was expecting. Let's think about what that second route would be. Aha, so it's going to be this route here because that is not. So one thing I'm kind of surprised by is that we're not getting 3 and 4 routes because we should be getting these routes here. But I guess there's no big reason to be surprised because if I go back up to my configuration, you can see I did not add those interfaces there. Otherwise, we would be seeing those. But I think it's fine just to not see those. Oops, and this is the wrong. device, but in this device, oops, it looks like I didn't print out the whole show run. Let's print out the whole thing. Okay, well, this is interesting. Oh, so I'm only showing the interfaces section. Okay, so now we can see on this device, yep, I did not add those. So I think that's going to be totally fine though. Let's do a show neighbors on this one as well. Okay, and then a show route, protocol OSPF 3. Okay, so same thing. So everything looks good to go on these routers. Let's close this and then open up router 2 and 4 and make sure they're good to go. Okay, so yep, we've got a level 1 and a level 2 adjacency to router 2. Looks good. So let's check the routing table. And yep, we've got those routes. So it's IPv6, it's not IPv4, but that's okay. We can just stick to IPv6. It's not a huge enough difference. We can create a routing loop in either IPv6 or IPv4. All right, so now let's try to create that loop. So to do that, I think what I'm going to try to do, first of all, is to take the route here and then redistribute that route into ISIS on over to router 4, because I want that route to be learned by router 1 here, and then to be learned by router 4, and then go around in a loop like this somehow. So I'm not sure how I can do that, but let's use this as the route where I try to figure it out. Oops, and this is router 2, but we can do a show and description because it's connected to router 4, or sorry, router 1. Okay. So it's going to be the :1 route, which is perfect. Okay, so let's try to make a redistribution policy on router 3 with that :1 route that will cause a loop, and we'll make sure to use a commit confirmed on our commit so we can tell, so we can roll that back and not have it just completely flood and crash the lab. I wish I could do a commit confirmed like 10 seconds or something, because loops can really make a big problem fast. 3 minutes is an eternity when it comes to computers, but this will have to, this is all I have, I think, is the minimum value. Yeah, oh, it looks like I can do 1, so I think that'll be a better value to use. So let's do edit policy options, policy statement, redistribute, set from protocol OSPF 3, set to protocol ISIS. Okay, so let's try that, and let's do a commit confirm to 1. Now I have a feeling this won't cause a loop because Because I don't have ISIS set up on this router. I think if I set up both, I think I would need to set up both ISIS and OSPF in order for this particular policy statement to work. Another reason this policy statement won't work is because I don't have it called anywhere. I just have it defined. So there's more configuration to do. Let's go into the edit protocols ISIS. Let's go edit protocols, show pipe display set relative. Okay, so now let's do activate ISIS, show pipe display set relative. Okay, so that looks good. And now let's do edit interfaces, show pipe display set relative. So let's do activate 0, 1, 2, and then also hello 0. Oops, so we're not, we gotta put the full statement in there. Oops, let's do a commit confirmed. Well, let's I almost did a commit without the confirm. Well, let's do a edit protocols ISIS, and then a set import redistribute. Okay, so now let's do a commit confirmed 1. But before we do that, let's set up traffic statistics monitor on the link to router 3. Okay, so monitor interface. Okay, so now we've got our traffic statistics. Okay, so let's see if these changed at all. Okay, so they changed momentarily. But they don't seem that bad. I would expect there to be a ton of input bytes if it were, in fact, a routing loop. I would expect that to grow exponentially and just never, ever go back down. Okay, so I think I will need a second redistribution policy where on this side I redistribute the same route from ISIS over to OSPF, so it'll go in a loop that way. And then if I have any one of these not confirmed, it won't cause a loop. So let's try that. Okay, so everything looks good here. Yeah, so let's do a commit on this side, but we won't, at this time we will do a full commit because we saw that appeared to have been safe. Oops, it looks like if you do a commit, but you don't do if you do a commit confirm, but you don't do a commit afterwards, you can't do another commit after it has been rolled back. Yep, so access has been revoked. So unfortunately, you lose your ability to commit what was committed before. But I think what you can just do, because it does actually roll it back, is you can go into another commit session, do a rollback 1, and now you can do the same. Yep, you can do the same configurations you did before. So here I'll just do a commit and quit because that appeared not to have caused a loop. Okay, and now we'll commit confirmed this one. Oops, but it's not supported for private. Shoot, and I've got a, well, let me just do this. Don't discard them. And then let's do an edit, or let's do a show policy options, pipe display set relative, show protocols, ISIS, or sorry, not ISIS, OSPF, pipe display set relative. Okay, so now we can do an exit, yes, discard them, configure exclusive, and now we can just paste these in. Oops, but we did a display set relative. That was probably not the right one to use in that case, but it's just as easy as going into the hierarchy level. So edit, yeah. Perfect. Okay, so now we can do a commit with confirmed 1, and hopefully we'll see these spike way up and never ever go back down. Okay, so I really don't see that happening. Yeah, so obviously my conception about how to trigger a loop is very flawed, but that's the whole point of what we're doing here now, is to try to learn and get a better sense of how this stuff works. So it's actually a good thing in my view that I didn't already know it, because otherwise there kind of wouldn't have been a point in continuing to practice if I was already really good at it. Okay, but let's go here and roll back this configuration just because I'm not sure what's going on. It seems like it's not a safe config for me, so I'd rather just pull it off and then work from a standpoint of what I know is safe, as opposed to a standpoint of what I am not sure of. Okay, so this will automatically be rolled back. So I'm going to pause the video here. I got to do some things quick. Well, maybe not quick, but I'll hopefully be back on it and finish this topic up by the end of the day. So I'll see you then. For now, I'm just going to pause the video and then I'll resume recording later. All right, so I'm back. Definitely feel good enough to keep going, so let's do that. So I already tried to create a running loop myself based on what I already know. So let's mark that as complete. Oops, it looks like my fly issue is coming back. For a few weeks it was perfectly fine. But, oh, now I got two of them. Okay. All right, so hopefully that wasn't too much of a delay. So let's get back and just do these two goals. It would be nice to be able to have enough understanding of layer 3 to be able to intentionally create a routing loop. I have proved that I do not have that understanding, but perhaps I will by the end of these exercises. So let's do these. All right, so let's fix up each of these. Let's actually blank out the configurations that are on there now. And we're not going to have a 6 router topology. We're just going to have a 4 router topology. But we should be able to replicate this somehow. All right, so yep, let's just replicate this configuration. We'll just go through and put it into action. All right, so let's start on router 1. All right, so we're going to keep the descriptions and we're going to keep the addresses. So let's delete everything under this hierarchy and then re-add that configuration. And there's no sense, I think, in worrying about the Linux jump hosts for now. Okay. So now we're going to need the addresses as well. Let's just concern ourselves with IPv4. There's no IPv6 in this example anyway. Okay, so, all right, so let's take care of the protocol section next. So we've already got some OSPF configurations, so let's clear that off of there. We'll just clear off the whole thing, I want to say. Well, why is the normal path the same as the backup path? For one, I guess it's a little different because the normal path is over T1 and the backup's over this SO. But why would you want a path, a backup path, to be so similar to the primary path? Like if there's a idiot with a cell backhoe, or you know, somebody didn't call the digger's hotline and they sever your cable, you know, wouldn't they sever this one too? Like if it's like, I would think a backup route would be like through here, or like, I don't get why this is a good idea for a backup route. Okay, let's kind of take it a bit easier, and let's just read the basics, because it's obvious that I don't have a lot of really high-level advanced knowledge in this. So let's start with, here we go. So CCNA, this is going to be the most basic level, I think. We've also got this for dummies. So let's start with the CCNA, because I already have the CCNA, so hopefully this will kind of make a lot of sense. Okay, so the simplest form of routing loop is indicated by figure 1. R1 needs to transmit data to R3. The best path is via R2 metric 3. For some reason, the link between R2 and R3 goes down, and R2 has not yet informed R1, but R2 also knows of another path to R3 through R2. A infinite routing loop has now occurred, and traffic just forwarded back and forth between R1 and R2, unless some mechanism exists to prevent this behavior. And I can't help but notice that they're selling a certification kit here with 3 switches and 3 routers, and it costs a good $200, maybe even $250 or $300 more than what I paid for my virtualization lab that is capable of studying for the CCIE. Of course, I don't have ASIC-based switches, and then I don't get layer 1 experience, but I save money and I can do more things. Types of routing loops. There are 2 types. Transient loops. Transient loops occur as part of the normal operation of the routing protocol due to different delays in routing information propagation. Once the protocol converges, the loop disappears. In figure 1, if split horizon and triggered updates are implemented, this loop will be avoided. Persistent loops in figure 1, up here. What happens if router R3 fails? R1 thinks R3 is reachable via R2 due to lower metric. R2 know that R3 is down, but it can reach it through R1. R1 will install the route to R3 via R1 with a metric of 12. The analogy is simple. Some bad information is better than no information. Again, traffic goes back and forth between R1 and R2, and the loop goes on indefinite. A good example is RIP. The loop persists until the metric reaches infinity. Hop count equals 16. The packet will be discarded. Persistent loops usually occur due to misconfiguration and require human intervention. They are also difficult to troubleshoot. A classic example is of route redistribution. In figure 2, R5 advertises 192.168.5.0/24 to R2 and R4 with a hop count of 5. OSPF and RIP are mutually redistributed at R2 and R4. The redistribution seed metric for RIP is 1. Let us consider the case when redistribution is performed at R4 only. R4 redistributes routes from RIP into OSPF. These routes propagated all the way OSPF domain and reaches R2. Okay, I think I'm going to stop reading this. There's just a lot of spelling and grammar mistakes, and I really don't feel like I'm getting a good sense of a routing loop from reading it. So let's see if this one's any better. A routing loop is a serious network problem which happens when a data packet is continually routed through the same routers over and over. Data packets continue to be routed within the network in an endless cycle. A routing loop can have catastrophic impact on a network, and in some cases completely disabling the network. Normally, routing loop is a problem associated with distance vector protocols. So that makes sense that I wouldn't have been able to trigger it with ISIS and OSPF, because those are not distance vector protocols. How routing loops affect network performance. A major portion of the precious bandwidth, which is available for normal user traffic of the affected routers, will be consumed by looping IP datagram packets. A major portion of the processing power of the affected routers is used to process the looping IP datagram packets. Routing loop can happen in large internetworks when a second topology change emerges before the network is able to converge on the first change. Convergence is the term used to describe the condition when all routers in an internetwork have agreed on a common topology. Link state protocols tend to converge very quickly, while distance vector protocols tend to converge slowly. The following methods are used to avoid routing loops. Maximum hop count. Maximum hop count mechanism can be used to prevent routing loops. Distance vector protocols use the TTL, time to live value, in the IP datagram header to avoid routing loops. When an IP datagram move from router to router, a router keeps track of the hops in the TTL field in the IP datagram header. For each hop a packet goes through, the packet's TTL field is decremented by 1. If this value reaches 0, the packet is dropped by the router that decremented the value from 1 to 0. Split horizon. A split horizon is a routing configuration that stops a route from being advertised back in the direction from which it came. Split horizon mechanism states that if a neighboring router sends a route to a router, the receiving router will not propagate this route back to the advertising router on the same interface. Route poisoning. Route poisoning is another method for avoiding routing loops. When a router detects that one of its connected routes has failed, the router will poison the route by assigning an infinite metric to it. Hold down timers. Hold down timer is another mechanism
used to prevent bad routes from being restored and propagated by mistake. When a route is placed in a hold down state, routers will neither advertise the route nor accept advertisements about it for a specific interval called a hold down period. Okay, so one thing that might be interesting to look at is, let's see if any of these methods of prevention had been triggered when I set up those policies.
Because it could very well be that I, in fact, did trigger a routing loop. It's just, since I'm using IGPs that are not distance vector, they had robust mechanisms to prevent the problems associated with routing loops, and it just shut it down, and I never got that never-ending spike in traffic because those mechanisms prevented that. So if that's the case, I want to see that. So let's see here. We'll do a rollback 1. Oops, and yeah, so I think we're good to have OSPF on there. So let's go rollback 0, exit, and now let's go on those triggering routers for the loopback. And I thought you would just need it on one of them. So let's just try rolling it back on router 3. Okay, so let's try this. And now let's see if there's any routes that are that have any of these characteristics. So let's sniff at least a few of these links. Let's sniff. Well, let's just sniff this link here. Well, actually, let's do this one. And then while that's opening up, let's do a show route. And let's do a show route hidden. Nope, so we don't have anything hidden. Let's do a show route protocol, OSPF. So we still got our 2 routes through OSPF. Let's do it on the other one as well. Oops, so rollback access is revoked. Oops, so there's some issue on router 2 where OSPF is not running. Because I did it for OSPF and not OSPF version 3. Yeah, let's just check if there's a. Nope, because it's version 3. Oh, so now I might get my loop. Huh. I should probably be checking for that. Because that might have been why I didn't get my loop before. Nope. So still looks fine. So let's see if the reason it's fine might be because there are protections that have been triggered. So here we've got ISIS and we've got hellos for OSPF. So let's, instead of these hello packets, let's try to get a different kind of packet. Let's try to get a link state update. So on here we'll do quit, and then we'll do clear OSPF 3, all, or database, all. Oh, well, let's do clear ISIS. Okay, so now hopefully we'll get a different kind of packet, not just a hello packet. Oops, it looks like it's the, nope, the bug isn't happening. Oh, okay, I think we got one of those packets for ISIS, but I want to get one for OSPF. So let's clear off router 3, and since these are all part of the same area, even though it's not the direct neighbor, we should be getting a an update. Oops, there's got to be OSPF version 3. Okay, here we go. So now this is where I would think that we might get a loop. Let's do a number of pings. All right, so let's just do a show route protocol direct. Sorry, not direct, local. All right, let's go to router 2 and ping some of these addresses. Oh, and these are the link locals, so I don't think there's any need to ping those. So nope, it still writes itself. So here's the dead interval. That's going to, or sorry, not the dead interval, the hold down timer. That's what's going to prevent against loops. The dead interval just determines whether or not a neighbor is valid. Okay, yeah, but I don't see anything. I'm kind of ready to finish the video. So let's just do some more reading, and then we won't have any lab exercises for this one. So it would be interesting to set up a static route. Oh, this could be it. The TTL is going down to 0. Let's see what the TTL is on some of these. Well, I didn't pick up any of the pings. But it would be interesting to see the TTL, time to live value, on some of the pings and see if they decrement a bunch. If they decrement it all the way down to 0, but
you know, as I said, we don't have to go super thorough into this one. It disappears sometimes. Oh, there it is. Okay, one thing I will try is kind of more like what they have in there. So I've got my policy set up so that it seems to me that it would create a loop. So let's create this one over here, and then let's try to ping end to end. And that will be the last thing in this video. I might devote another video to this topic, I'm not sure. But for now, we're just going to try this one final step in the lab. And if we get that message we saw in the For Dummies article, which is TTL expired in transit, we know we have created a loop. If not, this is probably a good one to read. So I'll add this to the notes. I'll add this to the notes as well. And then I'll add this to the notes. Yep, and network security is a tag because this is a danger to your network. Network is insecure if you're capable of having routing loops, especially if they can be triggered by a user. Okay, so I'm gonna, I think I'm gonna end the video right here, and then the next video I'll be trying that end-to-end ping, and then I'll be reading the Wikipedia article if that doesn't come. So that's the end of this video. Next video will be a short video, and hopefully I'll do it today, and we can get this topic done by the end of today. So thanks for watching. See you in the next one.